Hello and welcome to another Sleepy Science story. This is your time to slow down, to let the world soften at the edges, and to drift somewhere quieter for a while. Tonight, we're going to look up at something you've seen all your life, but perhaps never paused to wonder about for very long. The clouds. Those drifting castles of vapor, those soft sculptures of the sky, those weightless oceans that somehow manage to float above our heads. We'll unravel how they form, why they hover, and what secrets they hold inside, all in the gentlest way possible. I do hope this story isn't so interesting that it keeps you awake, but if it does, at least you'll have a head full of skyborne wonders to dream about. Before we set off, I'd love to know, where in the world are you listening from tonight? Whether it's late evening, midnight, or the early hours of dawn, let me know in the comments. It always feels magical to imagine these soft sky journeys reaching sleepy minds all across the globe. And if you find comfort in these calm wanderings, a gentle like and a tap on subscribe would mean the world. Thank you to everyone who's already part of this sleepy little corner. Remember, this is not advice of any kind, just a quiet place to rest, learn, and drift. So, take a slow breath, let it out gently, and allow yourself to imagine the sky above as we step softly into the science of floating clouds. The sky is rarely still. Even when it looks like an empty blue canvas above your head, there are always hidden rivers of air, flowing, curling, and lifting moisture into delicate shapes. Clouds are the gentle sculptors of the atmosphere, drifting overhead with a grace that feels timeless. They may seem like soft decorations, but each one is a marvel of physics, a slow work of art carved from vapor and sunlight. What makes them so captivating is how ordinary they appear, and how extraordinary they truly are. When you glance up, you might see nothing more than a cotton puff or a streak of silver, yet behind that simple form is an intricate story of invisible motion. High above, where the air cools and thins, water vapor begins its transformation. At first, it is impossible to see. Vapor is lighter than the nitrogen and oxygen molecules around it, so it quietly drifts upward like a thought rising into the mind. The higher it climbs, the colder the air becomes, and there comes a point where the vapor can no longer stay invisible. It condenses around the tiniest seeds floating in the air, perhaps a speck of dust, a grain of salt carried from the sea, or even a fragment of pollen swept up by the wind. On these tiny platforms, droplets form, so small they could hover for hours in the faintest breeze. Millions of these droplets gather together, and suddenly, what was once hidden becomes visible. A cloud has been born. From the ground, it looks as though the sky has simply painted itself. A white shape appears against the blue, as casual as a passing thought, yet inside that cloud is a secret world. Droplets rise and sink in gentle currents, colliding, merging, and separating again. Some freeze into ice crystals, others evaporate back into vapor, and all of them are caught in an endless cycle of change. To us, the cloud seems calm, but within it is a slow-motion dance of water and air. It is never the same for long. Edges form and dissolve as though someone is brushing and erasing the outline over and over. If you watch closely, you may see one side of a cloud building, while the other fades, proof that even stillness in the sky is never truly still. Clouds have a way of shaping the light around them. When the sun is high, they scatter the rays into soft brightness that makes the world glow without harshness. At dawn and dusk, their edges catch the low light and turn into palettes of fire and gold. Even the simplest flat grey blanket has its poetry, softening the day into a hushed pause. In every case, clouds take what is invisible and give it form, turning the unseen breath of the planet into something you can watch drift by. They are sculptors that work in silence, using nothing but warmth, air, and water. Each one is fleeting, a shape held only for a moment, then gone. Yet in that moment, a cloud reminds us that the sky is alive, not empty but full of motion and change, carrying oceans above our heads in forms as delicate as dreams. Every cloud begins with a journey that is almost impossible to see. The air around us is never truly empty. It carries an invisible ocean in the form of water vapor rising from seas, rivers, forests, and even our own breath. On a warm day, sunlight stirs molecules at the surface of water, giving them enough energy to escape into the air. They slip free one by one, lighter than the nitrogen and oxygen that surround them, and begin a slow climb skyward. Though invisible, this upward drift is constant and unbroken. Oceans, lakes, and leaves are always exhaling vapor into the air, feeding the sky in a cycle that has never paused since the planet was young. The climb of vapor is not always smooth. As the molecules rise, the air cools with height, and cool air cannot hold as much invisible moisture as warm air. At first, the vapor is content to stay hidden, floating like a ghost between molecules of air. But the higher it goes, the closer it comes to a threshold known as the dew point. This is the invisible boundary where air must let go of its secret. At that moment, vapor begins to gather, no longer able to drift apart, and clings to tiny particles suspended in the atmosphere. These particles are smaller than the eye could ever see, yet without them clouds could never be born. It is strange to think that something as mighty as a thunderhead, or as beautiful as a streak of cirrus, owes its existence to grains of dust or crystals of salt. Each droplet that forms is a small jewel balanced on a microscopic stage. Alone, such droplets are fragile, so small they would vanish back into vapor almost instantly. Together, they are strong enough to scatter sunlight and appear as a visible shape. In this way, vapor performs a kind of quiet alchemy. It transforms from unseen air into something solid enough to shade the ground and luminous enough to paint sunsets. The atmosphere is full of motion, so once vapor has crossed this threshold, it is carried upward and outward on rising currents. Over oceans warmed by the sun, this lift can be dramatic, sending plumes of vapor high into the sky where they blossom into towers of cloud. Over forests and fields, the process is more gentle, like a constant exhale that lingers above the trees. Even mountains play their part, forcing air to rise along their slopes until the cooling makes the invisible suddenly visible. In every case, vapor is on the move, changing state, gathering into something new. It is easy to forget that this process is happening all the time. Even when the sky is perfectly clear, vapor is still rising, still gathering, still searching for the right conditions to reveal itself. The still blue sky is only hiding the quiet work of evaporation and ascent. At any given moment, the atmosphere above us holds enough vapor to form an ocean a few centimeters deep if it were condensed all at once. The air is not empty. It is a transparent reservoir, always filling and spilling, always on the verge of transformation. When you look at a cloud, you are not just seeing vapor that has condensed. You are seeing the culmination of countless molecules that began as ocean waves, river spray, and drops on leaves. Their journey upward is soft and patient, never hurried, yet together they sustain the endless cycle of water between earth and sky. This is the hidden life of vapor, the breath of the planet, quietly building the foundations of every cloud. Without something to cling to, water vapor would never become a cloud. The sky might stay clear and empty no matter how. Much invisible moisture drifted upward. What makes the difference are tiny seeds scattered throughout the air, so small that most pass unnoticed. They are called condensation nuclei, and they can be almost anything. A grain of desert dust lifted high by the wind, a crystal of salt flung into the air from an ocean wave, a speck of soot from a faraway fire, even fragments of pollen drifting far from the plants that released them. Each one floats patiently until it meets vapor that has risen high enough to cool. The moment a molecule of water encounters one of these particles, it clings to it. Alone, a molecule would not stay in liquid form for long, but anchored to this invisible seed, it can gather companions. One becomes two, two become dozens, and soon a droplet is born. It is still unimaginably small, far too tiny to fall, but when millions of such droplets cluster together, they scatter light. What was hidden suddenly takes on form, and the faint outline of a cloud begins to appear against the sky. It is remarkable that something as grand as a billowing cloud begins with something so humble. Without dust or salt or pollen, the air could hold vast amounts of vapor and still remain clear. Clouds need these specks, as though each one is a quiet invitation for water to show itself. In this way, clouds are a collaboration. They are not just water or air, but a partnership with particles carried from deserts, forests, seas, and fires. The breath of the world becomes the skeleton of the sky. Inside a newborn cloud, droplets drift along in rising and falling air currents. They collide gently, sometimes bouncing apart, sometimes fusing together. Each seed that first invited the vapor in is still hidden inside, unseen but essential. Even the heaviest storm began with this same fragile process, a single droplet clinging to a mote of dust. When sunlight strikes a cloud, it bounces off countless droplets at once. Because they are so small, light scatters in all directions, turning the cloud into a glowing presence above. The bright white of a summer cumulus is really the combined reflection of millions of droplets, each one carrying its tiny core of dust or salt. At sunrise and sunset, when light travels farther through the atmosphere, the droplets scatter longer wavelengths of red and gold, giving clouds their colors. Once again, the invisible seeds shape what we see, not just in form but in hue. It is strange to realize that every cloud drifting over your head is filled with fragments of the earth beneath your feet. The sky holds deserts, oceans, forests and fires in suspension, lifting them upward and wrapping them in water. Each particle carries its own story, and together they make the clouds we know. These seeds of condensation are not only the beginning of weather, but also a reminder of connection. The air we breathe, the land we walk, and the sea we sail all find their way upward, carried quietly into the sky to build the drifting palaces of vapor that shade and soften the world below. A droplet's life inside a cloud is quieter than a whisper, yet more eventful than it might appear from below. It begins impossibly small, a sphere of water balanced on a particle of dust or salt. Alone, it would be too delicate to survive. Air currents would pull it apart, or the warmth of sunlight would send it vanishing back into vapor. But inside a cloud, there are countless others just like it. Together, they create a hidden community, suspended high in the air. The droplet drifts in currents that are constantly shifting. Warm air rising from the surface below lifts it higher, where the temperature is cooler and the pressure is lighter. Here, it may freeze into ice, or it may remain liquid, supercooled but still unfrozen, a fragile state that can last for hours. Then, the air may carry it downward again into warmer layers, where it melts if it had frozen, or warms if it remained liquid. The droplet's world is in constant motion, and yet from the ground the cloud above looks so still, a motionless shape drifting slowly across the sky. Every so often, the droplet brushes against a neighbor. Sometimes, they bounce away from each other, too small and too fast to stay together. Other times, they merge, and two tiny spheres become one slightly larger sphere. With each union, the droplet grows heavier, even if only by the tiniest fraction. Over and over, this process repeats, a slow and delicate dance of chance encounters. For some droplets, the journey ends quickly, vanishing back into vapor or failing to merge with enough partners to grow. For others, the collisions slowly add up until they have enough weight to fall free from the cloud. From inside, the view would be extraordinary. Light bends through each droplet, scattering into countless rays that make the cloud glow. To an observer standing within, the space would be filled with shimmering points of brightness, each one refracting the sun into a miniature rainbow. The droplets themselves would seem suspended in slow motion, shifting and gliding on air currents so gentle that movement becomes a kind of drift. Time inside a cloud would feel slower, more drawn out, as if every moment lingers. What makes this process so enchanting is its fragility. The droplet's survival depends on a balance of forces so delicate that the smallest change can erase it. A dry gust of air can evaporate it. A sudden surge of rising warmth can send it higher into colder regions, where it freezes. Even when it grows larger through collisions, it must remain whole against the pressure of falling air. Yet despite all these challenges, some droplets do endure, slowly gathering enough weight to begin their descent. When you look up at a cloud, what you are really seeing is millions of these droplets in the middle of their hidden lives. Each one is rising, falling, merging, or dissolving. Each one is part of a vast and fleeting architecture that builds itself out of nothing but air, water, and motion. The next time you see a patch of white drifting above, it might be worth remembering that it is not a solid thing at all, but a congregation of droplets, each with its own story of birth, growth, and transformation, waiting for the moment when it will finally let go and fall back to earth. It seems impossible that clouds can float. Water feels heavy when you pour it from a jug, and even a small bucket has enough weight to strain your arms. Yet above us, entire oceans drift in the form of clouds, carrying hundreds of tons of water while appearing as weightless as breath. The secret lies in scale. A cloud does not hold its water as a solid block. Instead, it is made of countless droplets so tiny that gravity has little power over them. Each droplet is suspended by the same air that carries dust motes in a sunbeam. Air itself is never still. Warmth from the surface of the Earth rises constantly, carrying invisible vapor with it. As that vapor cools and condenses, droplets form, and the same rising air that lifted the vapor continues to support the droplets. Updrafts can be strong or faint, steady or turbulent, but even the gentlest motion is enough to balance the fall of droplets this small. A typical cloud droplet is no wider than a human hair. On its own, it would drift downward slower than a feather, so slow that an upward breath of air can hold it in place indefinitely. With millions of droplets suspended together, the effect is a visible cloud that floats easily above the ground. From below, a cloud may look like a solid object, as though you could stand on it. In reality, it is more like a mist spread across the sky. If you were to fly through one, you would not bump into a solid wall. You would find yourself surrounded by damp, cool air, as though the sky had turned into a fog. The illusion of solidity comes from the way droplets scatter sunlight, not from any actual firmness. They glow and shine so brightly that they create the impression of weight and mass. Still, even in this delicately balanced system, gravity is never gone. The droplets within a cloud are always tugged downward, only to be lifted again by rising air. For as long as the upward and downward motions remain in balance, the cloud drifts gracefully, changing shape but staying afloat. When the balance tips, droplets merge into larger drops, too heavy to remain suspended. That is when rain begins. Until then, a cloud is like a tightrope walker, perfectly poised between two opposing forces. What makes clouds even more remarkable is their persistence. They may carry hundreds of tons of water, yet they can float for hours, sometimes for days, held aloft by nothing more than air currents. The same process works in clouds across the Earth, from thin cirrus streaks miles above the ground to towering thunderheads that rise higher than mountains. In every case, it is the smallness of droplets and the ceaseless rise of air that allow something so heavy to appear so impossibly light. The next time you look up at a drifting cumulus, imagine the paradox it represents. It is a vast collection of water, as heavy as a lake, yet it hangs in the air like a thought. Clouds remind us that even the heaviest things can appear weightless if they are divided into small enough parts and given the gentle support of motion. They are lessons in balance, carried silently across the sky. Cumulus clouds are the ones most people imagine when they picture the sky on a fair day. They rise like bright mounds of whipped cream, rounded and soft, almost playful in their appearance. Children draw them as simple white puffs, and artists paint them as cheerful shapes floating above rolling fields. Their very presence often makes the day feel light-hearted. Yet behind that friendly face lies a complex and fascinating process, one that begins with warmth rising invisibly from the ground. When sunlight warms the Earth, the surface responds by heating the brunero, air, just above it. That warmer air becomes lighter than the cooler air around it and begins to rise. As it climbs, it carries with it invisible water vapor, lifted from soil, rivers, and leaves. The higher it goes, the cooler the air becomes, and eventually, the vapor condenses into droplets. What started as nothing more than a pocket of warm, rising air grows into a billowing cloud, piling upward as though it is building itself from the ground into the heavens. Each new bubble of warm air that rises adds to the base, giving the cloud more material to stack upon itself. From below, you see this growth as soft towers building slowly but steadily. The tops of cumulus clouds often resemble cauliflower heads, lumpy and rounded, while their bases remain flat and darkened by shadow. This flatness marks the altitude where the rising air has cooled enough for condensation to begin. Above that line, the sky is filled with droplets, scattering light and making the cloud appear brilliant white. Below that line, the air is still too warm and dry for a visible cloud to form. The contrast between the shadowed base and the glowing crown gives cumulus clouds their classic storybook look. Inside, the atmosphere is anything but still. Warm air continues to rise, carrying new vapor to higher altitudes where it condenses and adds to the cloud's volume. Droplets are in constant motion, bumping together, sometimes merging, sometimes evaporating again. The entire cloud is a slow, bubbling pot, rising and collapsing in waves that take place too slowly for the eye to follow. From the ground it looks calm and serene, but within, the air is alive with hidden motion. Not all cumulus clouds remain small and cheerful. Some continue to grow, fed by strong updrafts, until they stretch high into the atmosphere. These can become towering cumulonimbus, the kind of clouds that bring rainstorms and thunder. But the small fair-weather cumulus, the kind that drift lazily across a summer sky, are harmless companions. They mark places where the earth has breathed a little more strongly, sending up enough warmth to form a visible shape, but not enough to build a storm. Standing beneath them, it is easy to imagine reaching up and scooping a handful, though of course nothing solid would come away. Entering such a cloud would feel more like walking into mist, damp and cool, with droplets brushing gently against your skin. The illusion of solidity is only that, an illusion born of scattered light and crowded droplets. And yet, the feeling they inspire is no less real. They remind us that the atmosphere is alive, full of hidden cycles of heat and moisture, always reshaping itself into forms that drift by like soft thoughts against the blue. Stratus clouds are the quiet companions of the sky. They do not tower or swell like their cumulus cousins, nor do they streak across the heavens like cirrus. Instead, they stretch wide and low, often covering the entire horizon in a blanket of grey. Their presence changes the mood of the day, softening sunlight into a dim, even glow. The world beneath feels hushed, as though wrapped in a muted quilt, where sound seems subdued and colours appear gentler. Unlike the puffy, bright clouds that grow from strong updrafts, stratus clouds are born from calm emotions. They form when a broad layer of moist air is lifted gently and evenly, cooling just enough for droplets to appear. The process can happen along coastlines where sea air drifts inland and rises, or across valleys where cool nights let vapor condense close to the ground. Sometimes they arrive as fog that has lifted only slightly, a reminder that clouds and fog are not so different, only separated by height. Looking up at stratus clouds, you may feel as though the sky has lowered itself closer to the earth. Their bases often sit not far above rooftops or treetops, especially in the early morning. The effect is intimate. It feels as though the boundary between the world below and the sky above has thinned. The horizon softens, shadows fade, and the day becomes evenly lit, without the contrasts of bright sun and dark shade. For many, it feels calm, though some might call it dreary. In truth, stratus clouds are not gloomy by nature. They are simply understated, preferring to linger quietly rather than draw attention. Inside these clouds, droplets are small and evenly spread. There is little turbulence, so they do not build the dramatic towers seen in storm clouds. Instead, they are layered, almost like sheets of fabric stacked together. Sometimes they bring light drizzle, a fine mist that barely wets the ground. Other times they hold their moisture without release, simply drifting across the landscape in silence. They rarely produce heavy rain or thunder. Their power is subtler, shaping the quality of light and the atmosphere of the day. There is a strange comfort in stratus clouds. They soften the edges of the world, muting bright glares and harsh contrasts. A city street under stratus feels quieter, the bustle softened by the grey veil above. A forest feels more enclosed, as though it has been drawn into a private room beneath the low ceiling of cloud. Even the sound of footsteps or distant traffic can seem subdued, wrapped in the same stillness that the cloud imposes on the light. When the sun is strong enough to break through, stratus clouds dissolve as quietly as they arrived. Their edges fade, their cover thins, and the blue returns. But while they last, they create a mood unlike any other type of cloud, one of stillness and pause. They remind us that not every part of the sky must be grand or dramatic. Some parts are content simply to linger softly, spreading calm across the landscape. Stratus clouds are the sky's quiet blankets, settling over the earth with patience, reminding us that beauty often lives in understatement. Far above the familiar puffs of cumulus and the grey blankets of stratus, there are clouds, so delicate, they look more like brushstrokes than structures. These are cirrus clouds, the high wanderers of the sky, stretched thin into wisps and curls that seem to drift like strands of hair combed across a pale blue canvas. They live where the air is so cold that water droplets cannot survive in liquid form. Instead, cirrus are built entirely from ice crystals, each one sparkling as it catches the sunlight before falling slowly through the thin air. Because they dwell at such heights, cirrus clouds are often the last to fade from view when the sun sets. Long after the ground has slipped into shadow, their slender forms still glow with warm colours, catching light that skims across the curve of the earth. They shine in pinks, oranges, and silvers, giving the impression that the sky itself has kept a few embers burning after the day has ended. At dawn, they are the first to greet the morning, glowing faintly while the rest of the world is still dim. In both cases, they act like messengers, carrying light where none should remain. The shape of cirrus clouds tells us something about the winds that sculpt them. High in the atmosphere, strong currents sweep across the sky, pulling the crystals into threads and curls. Sometimes they appear as long, feathery streaks stretching from one horizon to the other. Other times they twist into hooks or scatter like fine down plucked from a pillow. Their beauty lies in their impermanence. They are constantly being reshaped by the air around them, appearing solid one moment and dissolving into invisible vapor the next. Though they look fragile, cirrus clouds play an important role in the balance of the atmosphere. Their thin crystals scatter sunlight, sometimes dimming the heat that reaches the ground, sometimes trapping warmth that radiates upward from the earth. They are part of the planet's subtle thermostat, balancing heat in ways we cannot always see. Scientists study them carefully because even small changes in their patterns can affect climate. Yet for most of us, they remain nothing more than a sign that the sky is wide and high, and that air flows endlessly above our heads. If you were able to stand among cirrus clouds, the experience would feel otherworldly. The ground would be far below, hidden under layers of blue and haze. Around you, countless tiny crystals would drift slowly, each one glinting like dust caught in a shaft of light. There would be no sound, only the faint rush of wind too thin to carry more than a whisper. The horizon would curve, the sun would shine sharp and white, and the stars might be visible even in daylight if the sky were dark enough. It would feel less like standing in a cloud and more like standing inside a dream of light and frost. Cirrus clouds remind us of the sky's higher reaches, places most of us never touch but always see. They are faint signals of motion, evidence that the air above is alive with currents too distant for us to feel. When you notice them curling across the heavens, it is worth pausing for a moment to admire their quiet artistry. They may seem slight, but they carry the grandeur of the atmosphere itself, a reminder that even the thinnest veil can shape the light of an entire sky. Nimbus clouds are the great storytellers of the sky, and when they arrive, the world beneath them changes. They are heavy with water, dark in their bellies, and thick enough to dim the daylight into something resembling dusk. Where cumulus appear bright and playful, and cirrus stretch thin and delicate, nimbus carry a sense of weight and inevitability. They do not simply decorate the heavens. They announce themselves with shadow and promise, for when a nimbus cloud forms, rain is never far behind. The name comes from a Latin word for rain, and it fits perfectly. A nimbus is a cloud that has grown so dense and saturated with droplets that it can no longer hold its contents aloft. Inside, countless droplets have collided and merged, gathering into larger drops too heavy for air currents to support. What begins as mist within becomes rain that must fall, and the cloud itself darkens as sunlight struggles to pass through the thick mass of water. To look up at a nimbus is to look at a sky that has decided to release its weight back to the earth. From the ground, these clouds can seem immense, stretching from horizon to horizon, their lower edges blurred by falling sheets of rain. The air feels different beneath them. It grows cooler, heavier, and sometimes charged, as if the atmosphere is holding its breath. Shadows lengthen, and colors fade until the entire landscape seems subdued. Even sound changes. The world quiets in anticipation of the patter of rain, and when it begins, the rhythm of falling water becomes the dominant voice of the moment. Inside a nimbus cloud, the story is restless. Droplets swirl in turbulent currents, some rising, some falling, others caught in endless loops of evaporation and condensation. Temperatures shift as the cloud's immense body interacts with the air around it. In some places, droplets remain liquid even below freezing, fragile in their supercooled state until they strike something solid and freeze instantly. In other places, ice crystals and water droplets coexist, competing for moisture in a quiet struggle that ultimately feeds the falling rain. The cloud is not a single solid object. It is a complex machine of air, water, and energy, and its only conclusion is to let go of the water it holds. When nimbus clouds build into towering cumulonimbus, they bring with them not just rain but thunder, lightning, and sometimes hail. These vast sky mountains are capable of rising higher than the tallest peaks on Earth, their flat anvil-shaped tops brushing against the boundary of the stratosphere. Yet even a smaller, quieter nimbus, one that brings only steady showers, holds its own quiet grandeur. It replenishes rivers and fields, nourishes forests, and cleans the air as the falling drops carry dust and pollen back to the ground. There is a kind of poetry in standing beneath a nimbus cloud. The sky above feels impossibly vast, yet its presence is close and intimate, pressing down with the promise of rain. When the drops finally fall, they link the heavens and the earth in a single gesture. It is a reminder that clouds are not only floating sculptures, they are the lifeblood of the planet, carrying water through endless cycles, always returning it in moments of softness and storm. From the ground, a cloud can seem like a still shape fixed against the blue. It drifts slowly, perhaps reshaping its edges, but otherwise appears calm and motionless. Inside, though, the story is very different. A cloud is never still. It is a place of constant change, where droplets rise and fall, merge and evaporate, and where invisible rivers of air carve endless patterns. To step into a cloud would be to step into a quiet storm of motion, one too subtle and slow for the eye to follow, but powerful enough to shape the weather we live beneath. Air within a cloud is always moving. Warm currents lift droplets upward while cooler air sinks, creating gentle circulations that stir everything inside. This motion is what keeps countless tiny droplets suspended rather than letting them fall. If you could watch closely, you would see droplets dancing, swirling in small eddies, brushing against one another, sometimes clinging together, sometimes pulling apart. The entire cloud becomes a living system, changing from moment to moment even while its outer edges seem calm. As air rises inside, droplets grow larger. They may bump and merge with neighbors, adding weight until gravity begins to tug them down. Before they can escape, they may be carried upward again by another rising current, only to begin the cycle once more. Evaporation works alongside condensation, with some droplets shrinking and disappearing even as others grow. A single pocket of air can hold both, creation and loss, droplets appearing while others vanish back into vapor. This constant exchange is what gives a cloud its soft, shifting outlines. The edges you see from below are not fixed boundaries but zones where droplets are born and erased in an endless cycle. Sometimes the movement is visible if you watch carefully. One side of a cloud may appear to build while the other dissolves. Edges curl, stretch, and fade, not because the entire body is drifting away, but because air currents are painting and erasing the surface at the same time. A cloud is not a static object carried by the wind. It is a process, a visible intersection of moisture, temperature, and motion. The inner turbulence also shapes how a cloud looks from outside. Strong rising currents build towering cumulus forms with cauliflower-like tops, while steadier, more uniform motion produces the flatter layers of stratus. At higher altitudes, powerful winds shear the tops of clouds into wisps, spreading them thin across the sky. What we see is only the outer trace of a hidden architecture carved by air. It is remarkable to think that every cloud is a temporary balance, formed from forces that could just as easily scatter it into nothing. Warmth, coolness, vapor, and motion must all align just enough to sustain it. The still white shape we see above us is the outer mask of this restless interior. A cloud is never still, even when it seems to be. It is a moment in motion, a fleeting sculpture built from countless invisible currents that never truly rest. Clouds are more than gatherings of vapor. They are also the painters of the sky, shaping the light that reaches us and coloring the world in subtle and dramatic ways. Without them, the heavens would be a uniform blue during the day and a simple fade of orange and purple at sunset. With them, the sky becomes a shifting canvas, constantly rearranging its hues. A cloud does not merely exist in light, it transforms it, bending, scattering, and softening it until the whole scene below feels different. When sunlight strikes a cloud, it encounters countless droplets or ice crystals. Each one is tiny, yet together they scatter the rays in every direction. This scattering is what gives most clouds their bright white appearance. The droplets are just the right size to reflect the full spectrum of visible light, so no color is lost, and the result is a glowing whiteness that seems to float above the earth. On clear days, small cumulus clouds gleam brilliantly against the blue, their tops shining with a brightness that can almost rival snow. Not all clouds look the same, of course, and much of that difference comes from the way they handle light. Thin clouds like cirrus let sunlight pass through their icy crystals in a way that creates halos or faint rings around the sun and moon. Thick clouds, like nimbus, absorb more light than they scatter, giving them their dark, heavy underbellies. In both cases, it is the same sunlight, but the thickness and structure of the cloud decides whether the sky appears cheerful, ominous, or mysterious. The time of day adds even more artistry. At dawn and dusk, the sun's rays travel a longer path through the atmosphere, filtering out the shorter blue wavelengths and leaving the warmer reds and oranges. Clouds catch this filtered light and spread it wide across their surfaces. A flat sheet of stratus becomes a glowing ceiling of rose and gold. A billowing cumulus turns into a sculpture of fire, each curve outlined in crimson. Cirrus clouds high above the earth hold onto the last traces of sunlight long after the ground has gone dim, glowing like strands of silk suspended in the twilight. Without clouds, the sunrise and sunset would be brief and subdued. With them, they become spectacles of color that can linger in the memory for years. Even at night, clouds continue their work as painters. They reflect the faint glow of cities, turning the sky into shades of amber or grey. They scatter moonlight, softening its sharp edges and creating halos that seem almost magical. They can hide the stars completely, or reveal them in fleeting patches, framing constellations as though the heavens were shifting curtains on a stage. What makes clouds so enchanting is the way they remind us that light is never fixed. It is always being bent, scattered, or softened by the world it passes through. Every cloud you see is an artist at work, taking the steady glow of the sun or moon and turning it into something fleeting and new. They are the brushes of the sky, painting in colors that exist only for a moment before vanishing into memory. There are moments when the sky seems to shift into a palette that feels otherworldly. Before a storm arrives, colors appear that do not belong to an ordinary afternoon. Greens, purples, and deep bruised blues spread across the horizon, making the air feel charged with something unusual. People notice it instinctively, even if they do not know why. The world seems altered, as though nature has changed the stage lighting before a dramatic scene. These colors are not accidents. They are the work of clouds heavy with water and the particular ways they bend and filter sunlight. When a storm cloud swells, it gathers so much water that light struggles to pass through it. The longer wavelengths of red and yellow are often scattered or absorbed, leaving cooler hues to dominate. Sometimes, the layers of droplets and ice crystals refract light in ways that emphasize green or violet tones. The effect can be haunting. A field that looked golden in the morning may suddenly glow an eerie shade of jade beneath a storm-laden sky. The shift can happen quickly, adding to the sense of anticipation as thunder rumbles in the distance. Green skies, in particular, capture attention. They often appear in the late afternoon or evening, when the sun is low and the light must travel through more atmosphere. The longer path shifts the balance of colors so that when sunlight filters through a thick storm cloud, green becomes more visible. Though it is not a sign of any one specific weather event, people have long associated green skies with severe storms. Perhaps it is because that unusual hue has so often been witnessed in the hours before heavy rain or hail. The connection lingers, making a green sky feel like a warning whispered from above. Purples and deep reds are more common at the edges of storms, when sunlight breaks through in fleeting shafts. The droplets in the clouds scatter shorter wavelengths and allow the longer ones to blaze through, turning the undersides of clouds into glowing embers. The result can be breathtaking, as though the storm is both fierce and gentle at once, offering its drama in color as well as sound. The sky becomes a layered canvas, where light and water paint together in ways that no hand could reproduce. Even the darkest blues of a storm carry meaning. They signal clouds that are thick and heavy, so dense that almost no light escapes. This deep shading amplifies the flashes of lightning when they come, making each burst of brightness more startling. The contrast between darkness and sudden light heightens the spectacle, reminding anyone watching that storms are not only weather, but also performance. To stand beneath such skies is to feel both small and deeply connected to the planet. The colors are fleeting, lasting only until the storm decides to move or dissolve. Yet in those minutes, the world below feels transformed. Shadows grow sharp, the air cools, and every leaf and stone seems to glow in the altered light. These storm colors are not illusions. They are the earth and sky working together to remind us of the power of water, air, and sunlight meeting in a moment of restless beauty. It is easy to look up at a drifting cloud and imagine it as something light and airy, a tuft of cotton floating across the sky. The truth is far more surprising. Clouds are heavy. A single fair-weather cumulus, the kind that dots the summer sky in bright puffs, can hold hundreds of tons of water. Larger storm clouds can carry millions of tons. If all that water were poured out at once, it would drench the ground below in an instant. And yet, instead of crashing down, clouds drift gracefully overhead, their weight hidden by the way they are built. The secret lies in how that water is distributed. A cloud is not a solid body but a collection of countless droplets and crystals, each one no wider than a strand of hair. Tiny on their own, they weigh almost nothing. Gravity does pull on them, but the downward tug is so weak at that scale that the slowest upward current of air can counter it. Inside every cloud, rising columns of warm air provide just enough lift to balance the fall of droplets. What seems like a heavy burden is carried effortlessly by the invisible breath of the atmosphere. To picture it, imagine holding a handful of mist. The moisture is there, but it feels almost weightless because it is divided into droplets too small to gather strength. Multiply that mist by millions upon millions, and you have the body of a cloud. Each droplet is fragile, but together they scatter light so effectively that they become visible as a glowing mass. The weight is real, but it is spread so finely that the air can bear it. Still, clouds do not float forever. As droplets collide and merge, they grow larger and heavier. Once they reach a certain size, no amount of rising air can keep them aloft. That is the moment they begin to fall as rain. Until then, the balance holds, and the cloud remains a suspended ocean, carried along by the winds that push and pull across the sky. This balance is delicate. A shift in temperature or pressure can change it quickly, causing a cloud to build, to dissolve, or to release its contents. The thought that something so heavy can appear so light has a quiet poetry to it. It reminds us that weight and mass are not always what they seem. When spread out across space and supported by motion, even an ocean can hover above us like a dream. Every time a cloud passes overhead, it is carrying water that once lay in seas, rivers, or soil, a water that will fall again to feed the earth. Its weight is immense, but its presence feels gentle. To stand beneath a sky full of clouds is to stand beneath rivers and lakes suspended in the air. Their weight is hidden, their burden made graceful by the laws of physics. They remind us that heaviness can be borne lightly, and that balance can make even the heaviest things drift as though they had no weight at all. Clouds do more than drift across the sky. They tell time in ways that clocks cannot. Long before people learned to measure hours with gears and pendulums, they watched the heavens for patterns. The shapes and rhythms of clouds became part of the calendar, marking not just the passage of a single day, but also the turning of seasons. Even now, if you take the time to look, the sky reveals its own clock, written in shifting veils of vapor. On a summer afternoon, the appearance of puffy cumulus often tells you that warmth is rising strongly from the earth. These clouds build through the hottest part of the day and often fade again by evening. Their daily rhythm matches the pulse of sunlight, swelling as the hours stretch toward noon and shrinking as the air cools after dusk. In contrast, the layered greys of stratus in winter settle low and steady, sometimes lingering for days without change. They belong to the slower pace of the colder months, when the atmosphere moves less energetically. Just by glancing at the sky, you can sense whether the world is in a quickened summer beat or the drawn-out calm of winter. Clouds also act as keepers of the seasons in a broader sense. The high, thin cirrus that streak across autumn skies often announce the approach of shifting weather. They form ahead of distant systems, like the opening notes of a song, that signal what is coming next. In spring, towering cumulus and sudden cumulonimbus reveal the restless energy of the atmosphere, eager to overturn the chill of winter with showers and storms. Each season has its cast of clouds, and though the boundaries blur, the overall story is written clearly enough to read. Travelers and farmers once depended on these sky clocks. The look of a morning sky could hint at what the afternoon would bring. The colors at sunset could suggest whether tomorrow might be clear or troubled. Shepherds watched for rolling banks of grey that meant rain would soon touch their fields. Sailors tracked cloud lines across the horizon to judge wind and weather. These practices were not superstition but observation, passed down over centuries until they became part of human memory. Clouds were timekeepers for those who lived by the rhythm of the land and sea. Even today, when satellites and forecasts explain the atmosphere with precision, there is comfort in noticing how clouds tell the hour in their own way. The slow drift of afternoon cumulus, the fading glow of cirrus at dusk, the heavy ceiling of stratus before dawn, each is a gentle reminder that time is moving whether or not we glance at a clock. Their stories are written across the heavens for anyone willing to look up. Clouds may not tick or chime, but they measure time all the same. They count days in cycles of building and fading, and they count seasons in patterns of color and form. To read the sky is to feel time as part of the living world, not only as numbers, but as shifting breath, always moving forward, always marking the passage of life on Earth. High within the coldest parts of clouds, where the air is thin and the temperature plunges far below freezing, a transformation takes place that feels almost like magic. Tiny droplets of water, suspended in supercooled states, begin to freeze onto the smallest of seeds. A speck of dust, a grain of salt, or even a fragment of ash, carried high by winds. What emerges from this union is not a simple lump of ice but a crystal with an elegant geometry. These are the beginnings of snowflakes, and they grow in silence, unseen by the world below. The secret lies in the way water molecules arrange themselves when they freeze. They naturally lock together in a six-sided pattern, forming a hexagon at the heart of every snowflake. No matter how intricate or simple the eventual design becomes, this six-fold symmetry remains. From this simple rule springs endless variety. As the crystal drifts within the cloud, it passes through layers of air with different temperatures and levels of moisture. Each change alters the way molecules attach to its surface. Sometimes the tips grow long and slender, stretching outward like icy needles. Other times the branches spread wide and sprout smaller arms, weaving into lacy, fern-like forms. The result is individuality. No two snowflakes trace the same path through the sky, and so no two grow in exactly the same way. A swirl of wind or a pocket of slightly warmer air can change the pattern in an instant. By the time a snowflake leaves the cloud, it carries within its delicate arms a record of its journey, a frozen diary written in geometry. From the ground it may look like just another flake among trillions, but up close it reveals its own story, one that will never be repeated. The birth of snowflakes shapes the clouds themselves. As ice crystals grow, they compete with the surrounding droplets, drawing vapor out of the air more efficiently than liquid water can. This process makes the crystals swell larger, while nearby droplets shrink and vanish. Over time, the ice becomes heavy enough to begin its descent, sometimes falling alone, sometimes clustering with others. Before it reaches the ground, it may pass through new layers of air, melting into rain or refreezing into sleet. But in the highest, coldest clouds, many crystals survive intact, drifting gently downward as snow. There is a quiet beauty in the thought that every snowflake begins with something as small as dust. The grand white blankets that cover mountains and fields each winter are built from countless invisible seeds, lifted into the sky and transformed by cold. Together, they change the face of the land, smoothing edges, quieting sounds, and storing water for the seasons to come. Yet each one, before it joins the collective, is an individual work of art, a fleeting sculpture shaped by chance. Snowflakes remind us that nature does not need repetition to create abundance. It thrives on variation, finding beauty in infinite small differences. Each flake is fragile, melting in an instant on a warm palm, yet together they hold power to shape rivers, carve valleys, and cool the planet itself. From the stillness of clouds, they emerge as quiet messengers of winter, each carrying a story only the cold air could write. On warm days, when the air is restless and rising, clouds can grow into forms so immense they tower higher than mountains. These are cumulonimbus clouds, often called thunderheads, and they are among the most dramatic creations of the atmosphere. They begin innocently enough as small cumulus clouds, puffy and harmless, drifting across a blue afternoon sky. But when the ground beneath is hot and the air carries abundant moisture, those harmless shapes can swell with astonishing speed, building upward until they dominate the horizon. The growth of a thunderhead is fueled by rising columns of warm air known as updrafts. As the sun heats the earth, the air near the surface becomes lighter and begins to rise. The higher it climbs, the more it cools, and the water vapor it carries condenses into droplets. Each droplet releases a small amount of heat as it forms, which warms the rising air even more and helps it continue its ascent. This cycle feeds on itself. The stronger the updraft, the taller the cloud becomes, often climbing tens of thousands of feet into the sky. From below, a thunderhead looks like a mountain of vapor, its base dark and flat, its sides rising in bulging towers. The top spreads outward into a vast anvil shape when it reaches the stable layers of the stratosphere. In that moment, the cloud has become a towering cathedral of air and water, stretching so high that its summit brushes against the edge of space where jet streams roar. To watch one grow is to witness the sky building its own monument. Inside the cloud, the atmosphere is alive with motion. Updrafts surge upward with the force of rivers, while downdrafts plunge downward carrying cooled air and rain. Droplets collide and merge, forming larger drops, while others freeze into pellets of ice that may become hail. The turbulence creates a kind of hidden storm within the cloud, long before the first raindrop touches the ground. Lightning flickers as charges separate between different parts of the cloud, and thunder soon follows, echoing through the sky like a drumbeat. Despite their drama, thunderheads are not only destructive, they are engines of renewal. The rains they release feed rivers, fields, and forests. Their lightning fixes nitrogen in the atmosphere, creating compounds that help nourish soil. They are both frightening and life-giving, a reminder that nature often carries balance within its power. To stand beneath one is to feel the scale of the planet, for a thunderhead dwarfs everything on the ground and reminds us how small we are beneath the architecture of the sky. As evening falls, the last light of the sun often turns the tops of these clouds into glowing towers of orange and gold. They look almost sculpted from fire, their edges sharp against the fading blue. Soon after, they may collapse, their energy spent, dissolving back into drifting vapor. But while they last, thunderheads embody the sky at its most ambitious, rising with force, glowing with light, and carrying both storm and renewal in their vast, towering forms. Inside every rain cloud there is a secret world of droplets. Each one begins as a microscopic sphere of water, born from vapor that has condensed onto a tiny seed of dust or salt. Alone, such a droplet would be too light to fall. It would hover almost weightlessly, carried by the faintest movement of air. But within the crowded interior of a cloud, droplets are constantly bumping into one another. Some collisions are gentle glances that end in nothing, while others merge two small droplets into one slightly larger drop. With every successful meeting, the droplet gains weight, its downward pull becoming stronger, though still balanced by the upward breath of air currents. This process continues for hours inside a living cloud. Billions of droplets swirl in rising and falling currents, weaving together in a kind of hidden dance. The larger ones fall a little faster and sweep up the smaller ones in their path, growing as they descend. Then another current may lift them upward again, returning them to colder heights where they continue to gather companions. The cycle repeats over and over until some droplets grow large enough that no current can hold them. At that moment, gravity wins and rain begins. The journey from vapor to raindrop is fragile. Many droplets never make it. Some evaporate back into invisibility before they grow big enough to fall. Others are swept aside, losing their size and vanishing into the air once more. Only a small fraction endure long enough to reach the ground. When they finally do, it is the result of countless invisible meetings and exchanges within the hidden chambers of the cloud. What looks to us like a simple shower is really the triumph of millions of droplets that manage to survive the intricate process of growth. The variety of conditions inside a cloud creates more than one path to rain. In the coldest heights, droplets can remain liquid even below freezing, suspended in a supercooled state. When they touch an ice, a crystal, they freeze instantly, adding to its size. Ice crystals grow rapidly in this way, fed by the vapor that surrounds them, until they become heavy enough to fall. On their way down, they may pass through warmer layers of air and melt, becoming raindrops before they reach the ground. In this way, some of the rain that lands on your hand may have begun as a snowflake high above, reshaped into liquid on the way down. From the outside, a rain cloud looks like a dark mass hanging above the earth. Inside, it is a factory of droplets, a place where vapor is constantly being sculpted into liquid and ice, only to be released when the balance can no longer hold. Every drop that strikes a window or ripples across a pond carries with it the memory of that hidden world. It began as vapor, gathered strength through countless encounters, and finally let go of the sky to return to the earth. The story of rain is not sudden or simple. It is a slow collaboration of air, water, and chance, working quietly above us until the moment we feel it on our skin. When the sun has set and the land below is wrapped in shadow, most clouds fade into darkness. They lose their color and dissolve into the night, leaving the stars to reclaim the sky. Yet there are times when a different kind of cloud appears, one that glows faintly even after the day is gone. These are noctilucent clouds, among the rarest and most mysterious sights the sky has to offer. They live not in the lower atmosphere where weather takes place, but far higher, close to the edge of space, where the air is thin and temperatures plunge to extremes. Noctilucent means night shining, and the name is fitting. Long after sunset, when the ground has grown dark, these clouds still catch sunlight that travels across the curve of the earth. From below, they appear as silvery, bluish veils stretched across the horizon, glowing faintly as if lit from within. Their delicate tendrils twist into ripples and halls that resemble waves on water, though they hang impossibly high above. To witness them is to feel as though the sky itself has kept a secret lantern burning while the world sleeps. The crystals that make up these clouds are smaller than those in ordinary clouds, formed from water vapor that clings to particles of dust drifting at the edge of space. Some of this dust comes from meteors that have burned through the atmosphere, leaving behind trails of tiny fragments. Other particles rise from the earth, carried higher than seems possible by strong currents. In the cold of the mesosphere, more than 80 kilometers above the ground, water vapor condenses onto these particles and creates thin clouds that shine with a ghostly light. Because of their height, noctilucent clouds are rarely seen. They are most common in the summer months at high latitudes, where twilight lingers long after sunset. Observers often notice them in the deep blue of late evening or very early morning, when the sun has dipped far below the horizon, yet still sends light to the high atmosphere. Their faint glow makes them look fragile, almost unreal, as though someone has brushed silver paint across the sky. Scientists study these clouds closely because they may carry clues about changes in the atmosphere. They have been reported more frequently in recent decades, leading to questions about whether rising levels of water vapor in the upper atmosphere are making them more common. At the same time, they remain elusive, appearing unpredictably and disappearing without warning. This mystery only adds to their charm, as if they are visitors from another world who choose their moments carefully. For those lucky enough to see them, noctilucent clouds leave a lasting impression. They transform an ordinary night into something luminous and dreamlike, a reminder that the atmosphere is larger and more complex than it seems. To stand under their pale shimmer is to feel both the vastness of the sky and the intimacy of its quiet wonders. They are clouds, but they are also messages from the edge of space, written in silver light against the darkness of night. Clouds are more than passing shapes that drift across the sky. They are active players in the climate of the Earth, quietly managing the balance of heat and light that makes the planet habitable. Every cloud, whether it is a thin cirrus stretched high above or a thick nimbus looming low and dark, participates in this delicate system. They cool, they warm, they shade, and they trap. Their presence shapes the rhythm of seasons and the comfort of every day. One of their most important roles is reflecting sunlight back into space. Bright clouds, especially thick ones like cumulus and stratus, act like giant mirrors. They scatter and bounce sunlight, reducing the amount of heat that reaches the ground. This effect is strongest in the tropics, where sunlight is most intense and clouds are frequent. Without this shielding, the Earth would be far warmer, and many regions would be inhospitable. In this way, clouds act as guardians, softening the heat of the sun and creating conditions where life can thrive. At the same time, clouds can hold warmth close to the surface. During the night, when the sun is gone, the Earth radiates heat back into space. Clear nights often grow cold quickly because nothing stands in the way of this escape. But when clouds linger, they absorb and re-emit that heat, keeping it near the ground. A cloudy night is noticeably warmer than a clear one, not because the air holds more energy, but because the clouds act like blankets, slowing the release of warmth. This balance between reflecting sunlight by day and holding heat by night is one of the reasons the climate remains stable enough to support life. Different kinds of clouds play different parts in this system. High cirrus clouds are thin and wispy, so they reflect little sunlight but trap more heat, slightly warming the surface. Low clouds, like stratus, reflect a great deal of sunlight but have less effect on trapping warmth, which tends to cool the surface. Towering cumulonimbus can do both, blocking the sun during the day and holding warmth at night. The overall impact of clouds depends on their height, thickness, and even the size of their droplets. The sky is like a vast orchestra, with each cloud type contributing its own note to the symphony of climate. Scientists continue to study clouds because their influence is both vital and complex. Small changes in cloud patterns can shift the balance of temperature and rainfall across entire regions. Climate models depend on understanding how clouds will behave as the Earth warms, yet predicting their movements remains one of the most challenging puzzles in atmospheric science. Will more clouds form to reflect sunlight and cool the planet, or will high thin clouds increase and trap more heat? The answer may decide how the climate changes in the future. For now, what is certain is that clouds are not just scenery. They are part of the planet's breath, regulating heat and light with every passing hour. When you look up and see them drifting, you're also looking at the machinery that keeps the world in balance. They are both beautiful and necessary, carrying within their soft forms the quiet power to shape the destiny of the Earth itself. The clouds we see above our own world are only one version of a much larger story. Other planets and moons carry their own skies, and within them, clouds form from materials very different from the water vapor we know. To imagine these alien skies is to realize that clouds are not just an earthly phenomenon. They are a universal outcome of vapor, temperature, and motion, wherever those ingredients exist. On Venus, the entire atmosphere is wrapped in thick layers of cloud. From the surface, if one could stand there, the sun would never be visible. The clouds are not made of water, but of sulfuric acid droplets, dense and choking, reflecting sunlight so efficiently that Venus shines brightly in our night sky. These clouds trap heat with incredible strength, driving surface temperatures to levels hot enough to melt lead. Though they are hostile to life as we know it, they are also strangely beautiful, glowing golden and pale when viewed through spacecraft cameras. Jupiter, the largest planet, displays clouds on a scale that dwarfs anything on Earth. Its surface is hidden beneath bands of swirling formations made of ammonia crystals and other compounds. These clouds stretch across thousands of kilometers, shaped by roaring jet streams that race in opposite directions. The Great Red Spot, a storm that has raged for centuries, is circled by such clouds, their colors shifting between whites, tans, and deep reds. To watch them is to watch an atmosphere in constant motion, painted in broad strokes of chemical weather. Saturn carries its own layers of ammonia clouds, but they are softer in appearance. From afar, Saturn's atmosphere looks smoother, with pale yellow and gold bands circling the planet. Yet even here, storms can rise. In rare moments, bright white spots appear, growing into tempests that encircle the planet and then fade back into calm. Clouds on Saturn are gentle in look but powerful in size, stretching farther than entire continents on Earth. Uranus and Neptune reveal still another style of cloud. In their deep blue atmospheres, methane plays the starring role. Methane absorbs red light and scatters blue, giving these planets their striking color. Within them, high clouds of methane ice drift like faint glowing streaks against the darker background. On Neptune, storms hurl these clouds into visible shapes that can be tracked across the planet's face, moving faster than any earthly hurricane. Even some moons carry clouds. Titan, Saturn's largest moon, has a thick atmosphere where clouds are made not of water, but of methane and ethane. They rain liquid hydrocarbons onto the surface, filling lakes and rivers with substances that would be unthinkable on Earth yet perfectly normal in that frigid world. To stand beneath Titan's sky would be to see clouds carrying a cycle of alien weather, as familiar in rhythm as our own, but utterly different in substance. Looking outward, we discover that clouds are not only decorations of the sky, they are signatures of atmosphere and chemistry, shaping light, climate, and even landscapes far from home. To imagine them is to realize that the drifting forms we see above us are part of a larger story told across the cosmos, wherever vapor rises, cools, and becomes visible. Above us stretches an ocean that most of the time we cannot see. It is not made of waves or tides, but of water vapor drifting in the air, rising from the earth in invisible streams. At any given moment, the atmosphere carries billions of tons of this vapor, enough that if it were all to condense, it would form a shallow sea covering the entire globe. This hidden reservoir surrounds us constantly, flowing and shifting, waiting for the right conditions to reveal itself as clouds, rain, or snow. The journey begins when sunlight warms the surface of the planet. Oceans, rivers, lakes, and even damp soil release water molecules that slip upward into the air. Forests contribute as well, with leaves exhaling moisture through tiny openings in a process known as transpiration. These combined breaths of land and sea fill the sky with vapor. Though water is heavier than the gases that make up most of the atmosphere, a single molecule of vapor is lighter than nitrogen or oxygen, so it floats upward naturally. With the help of rising warm air, these molecules climb higher, joining the invisible ocean above. Wind spreads this moisture across the planet. A molecule that leaves the Pacific Ocean might travel thousands of kilometers, crossing continents before falling again as rain. In this way, the hidden ocean does not remain still. It circulates endlessly, linking distant places in a single cycle. The drop of water in a storm today may once have been part of a glacier, a lake, or even a creature's breath millions of years ago. The atmosphere remembers and carries this water forward, passing it between sky and earth with steady patience. When vapor cools as it rises, it condenses around tiny particles and becomes droplets. If enough gather, clouds form. These clouds float because their droplets are so small that air currents can hold them, but they are only temporary shapes within the larger ocean. Eventually, the droplets merge and grow heavy enough to fall. What seems like a sudden shower or snowfall is simply the visible return of the ocean in the sky to the world below. Then, through rivers, soil, and roots, the water finds its way back to the seas, where the cycle begins again. To think of the air as an ocean is to realize how connected we are to it. Every breath we take adds a little vapor. Every field of crops, every forest canopy, every stretch of coastline is contributing to the hidden water above. This ocean is everywhere at once, yet never stays the same. It is a reservoir without shores, boundless and shifting, its tides marked not by the pull of the moon but by the warmth of the sun and the turning of the seasons. The next time you look up at the sky, even when it is perfectly clear, remember that you are standing beneath an ocean. Its surface is invisible, its currents silent, but it surrounds the planet as surely as the seas lap its shores. It is the breath of water itself, moving endlessly between earth and sky, always present, always flowing, always waiting to be seen. Sometimes the sky decides not to stay above us, but to come down and walk among us. That is what fog is, a cloud that has chosen to settle on the ground. It drapes itself across fields, rivers, and streets, blurring the familiar world into something softer and more mysterious. The sharp edges of trees, fences, and rooftops fade into pale outlines. Sounds become muffled, footsteps quieter, and distances shorter. It feels as if the world has paused and taken a breath, wrapped in a veil that hides detail but reveals calm. Fog forms when the air near the ground cools enough that it can no longer hold all the moisture it carries. The vapor condenses into tiny droplets suspended in the air, just as it does in higher clouds, only this time the condensation happens at our level. This cooling often occurs on clear nights, when the warmth of the day escapes into the open sky. The ground loses heat, and the air above it cools as well, reaching the dew point where droplets appear. By morning, a fog has settled, covering valleys and lowlands in silver. Other times, fog forms when warm, moist air flows over cooler surfaces such as snowfields or cold oceans. The air cools from below, and droplets condense, spreading the fog like a blanket across the landscape. On coastlines, this process creates the famous sea fogs that roll inland, bringing sudden greyness to otherwise bright days. Mountain valleys are also prone to fog, where cool air sinks and becomes trapped, holding moisture close to the ground until the sun warms it away. To walk through fog is to step inside a cloud. Each droplet is too small to see individually, but together they scatter light in all directions. This scattering is why fog looks white and luminous, especially when touched by sunlight or street lamps. It is also why visibility shrinks. Light cannot travel far without being bent and diffused, so objects fade quickly into grey. A tree only a short distance away can look ghost-like, its outline uncertain. The familiar becomes unfamiliar, transformed into a dreamlike version of itself. Despite its quiet beauty, fog can reshape daily life. It slows travel, hides roads, and challenges navigation. Ships at sea once feared it, relying on bells and horns to warn one another when sight failed. Pilots today use instruments to pierce through it, while drivers on rural roads move cautiously, headlights glowing in halos of mist. Yet at the same time, fog carries a certain peace. It invites stillness, encourages slower steps, and transforms ordinary landscapes into something hushed and timeless. When the sun grows stronger, fog begins to lift. Droplets evaporate back into invisible vapor, and the world emerges again in sharper detail. The spell breaks, and life resumes at its usual pace. But for a little while, fog lets us live inside a cloud, seeing the world softened and blurred. It reminds us that the boundary between earth and sky is never fixed, that sometimes the sky chooses to descend and share its secrets with us directly. Clouds do more than decorate the sky. They shape the light that reaches the earth, sculpting brightness and shadow across the land below. On a sunny afternoon, a single drifting cloud can turn a field from glowing gold to cool green in an instant. The movement of that shadow feels alive, sliding silently over hills and valleys, reminding us that the sky is not distant, but directly connected to the world we inhabit. These shifting patches of light and dark are the brush strokes of clouds, painting landscapes in motion. When sunlight passes through a clear sky, it falls evenly, with no interruption. But when clouds wander across the sun's path, they interrupt that light. Thick clouds block much of it, leaving broad swaths of shade. Thin clouds scatter and soften the rays, creating a diffused glow that makes colors gentle and edges less sharp. High ice clouds may even bend the sunlight into halos and arcs, spreading rainbow tints across the blue. In every case, the presence of clouds alters the way the earth is illuminated. Animals notice these changes as much as we do. Birds sometimes use the cooling shade of passing clouds as signals to adjust their activity. Grazing animals may rest when the sun grows harsh, then stir again when shadows bring relief. Even plants respond to the rhythm of light and shade, their leaves shifting to catch what brightness they can. A single cloud drifting across a meadow is not just a visual change. It is a shift in temperature, in behavior, in the quiet choreography of life. On hot days, the shade of clouds can feel like a gift. Standing beneath one, the drop in temperature is immediate, a small mercy delivered by vapor drifting miles above. Travelers across deserts once relied on such moments of shade, brief pauses in the relentless Sunday. Farmers still watch the play of clouds, knowing how light and warmth affect the growth of crops. Entire landscapes breathe differently depending on how the sky scatters its shadows. Cloud shadows also remind us of scale. A shadow can be vast, stretching across mountains, lakes and towns, yet move with the unhurried pace of the wind. Watching such a shadow drift can feel like watching time itself glide across the earth. The pattern is never fixed. A few minutes of looking upward shows clouds shifting, stretching, dissolving, and reforming, their shadows following suit. The ground becomes a stage where light and shade take turns without end. When evening comes, clouds continue their influence. They scatter the lowering sunlight, painting the world in warm tones, or they block it entirely, ushering in twilight before its time. At night, they reflect city lights or moonlight, creating a softer glow than the sharp darkness of a clear sky. In every hour, clouds are shaping how we see, even when we do not notice. To stand in a passing shadow is to feel the touch of the sky itself. It is a reminder that clouds are not distant ornaments but active companions, shaping light, cooling the earth, and drawing invisible patterns that connect heaven and ground. Clouds do not stay forever. Just as quietly as they appear, they vanish, leaving behind only open sky. Their disappearance can feel sudden, as though the sky has decided to sweep itself clean. Yet the process is not abrupt. It is the result of countless small changes happening within the cloud, each droplet shifting between being visible water and invisible vapor. The life of a cloud depends on balance. Warm air rising from the ground carries vapor upward, feeding droplets that form and gather. As long as this rising motion continues and the air remains moist, the cloud is sustained, but when dry air drifts in or the upward currents weaken, the balance tips, droplets no longer hold together. They evaporate back into invisibility, slipping into the air molecule by molecule. What once looked like a solid shape dissolves into blue, the cloud's edges softening until nothing remains. Sometimes this happens slowly. A cumulus cloud on a summer afternoon may spend hours building itself, growing tall and round, only to fade away as the day cools and the sun lowers. Its bright edges blur, its towers sag, and eventually it thins into wisps before vanishing entirely. At other times, the change is swift. A gust of dry wind can slice into a cloud and scatter it, tearing apart its structure until it is gone. From below, you see the shape unravel before your eyes, a reminder of how fragile these sky sculptures really are. Even the largest clouds are temporary. Thunderheads rise into towering forms that dominate the horizon, yet once their energy is spent, they collapse. Their anvils fade, their dark bellies lighten, and the rain they carried falls away. What seemed so immense becomes nothing more than vapor dispersed into the surrounding air. The sky that felt so heavy with drama just hours earlier opens again to calm blue. Disappearing clouds also change the mood of the landscape. When stratus blankets the world in grey, its departure feels like a lifting of weight. Light pours down more directly, colours sharpen, and shadows return. When cirrus dissolve high in the atmosphere, their faint streaks leave the heavens looking cleaner and more open. Each change alters the tone of the day, reminding us that the sky is never static, but always in motion, even when it seems quiet. It is comforting to know that clouds are part of a cycle. The water they release in rain or return invisibly to the air will rise again, form again, and drift again. The cloud you watch dissolve is not gone forever. It is simply changing form, moving into the next stage of its endless journey. Its disappearance is not an ending, but a pause before renewal. When you look up and see a cloud fading into nothing, you are witnessing the atmosphere at work, reshaping itself in ways both delicate and powerful. It is a quiet lesson in impermanence, teaching us that beauty can exist even in things that last only a moment. The open blue that follows is not emptiness, but space for the next story to appear, carried on the breath of the sky. The story of clouds is never finished. They rise, drift, and fade, only to begin again in another place and time. This eternal cycle is the quiet rhythm of the planet, carrying water from sea to sky and back to earth in an endless dance. Every cloud you have ever seen was part of this larger movement, a single chapter in a book that has been written since the beginning of the world. It starts with sunlight lifting vapor from oceans, rivers, forests, and soil. Molecules slip upward, lighter than air, gathering invisibly until they reach cooler heights. There, they cling to tiny seeds of dust or salt, forming droplets too small to fall. These droplets cluster together, scattering light, and suddenly the sky reveals a new shape. A cloud has arrived, drifting in silence across the blue. From the ground it may look calm, but inside it is alive with motion, droplets colliding, rising, sinking, freezing, and melting. The cloud grows and changes until the balance tips, and it lets go of the water it carries. The fall of rain or snow is not the end, but a continuation. Drops land on soil, seep into rivers, and flow back, toward the sea. Flakes gather on mountains, storing water that will one day melt and trickle downward to feed valleys and plains. Some of the water soaks deep underground, waiting for years before it resurfaces. Some of it evaporates almost immediately, joining the air again before it even touches the ground. No part of the journey is wasted. The cycle continues without pause, reshaping landscapes and sustaining life. Clouds are the visible moments of this process, the points where the invisible becomes tangible. They remind us that the air is not empty but filled with the breath of water, always moving between forms. A single cloud may last only an hour, but the water within it has been traveling for millions of years, falling as snow on ancient mountains, drifting as vapor over primeval seas, coursing through the veins of creatures long gone. When you watch a cloud drift past, you are watching history carried overhead, a story older than any human memory. There is comfort in this repetition. The same processes that shaped the skies of distant ages continue today, unchanged in their essence. Tomorrow, new clouds will rise from the same oceans and fall over the same mountains. They will drift in different shapes and scatter light in new colors, but their cycle will remain familiar. To follow the life of clouds is to follow the breath of the planet itself, steady and unbroken. As you lie beneath the sky, watching their shapes pass and dissolve, it is worth remembering that they are not fleeting decorations. They are part of an endless pattern, an eternal dance of water and air. Each one is a moment in a story that never ends, a gentle reminder that change and renewal are woven into the very fabric of the world. Clouds come and go, but their cycle carries on, rising, drifting, falling, and rising again, as it always has and always will. So, as you settle deeper into rest, remember this. Every cloud you've ever seen was born from invisible vapor, gathered into sunlight, and carried high by the sky's gentle breath. They are temporary, fleeting, but their cycle is endless, rising, drifting, falling, and rising again. The next time you glance up at a passing cloud, you might see not just fluff and shadow, but a floating ocean, a soft archive of the water that has circled this world for billions of years. And now, as you drift towards sleep, may your dreams be as light as cirrus clouds, as calm as stratus blankets, and as wondrous as the vast sky itself. Rest easy, sleep well, and let your thoughts float away like clouds on a quiet breeze. Good night.